welcome to CEC lectures. Myself Dr. Preeti Chagwani from Department of Computer Science, Aryabhat College, University of Delhi. So, presently we are learning the database management system in the form of a lecture series, and under this today's topics is about the views. Now, before going into the details of the views, let me recall that we have seen in the initial lectures of database management system, we have seen a three-level kind of model of database structure or databases. The bottommost level was the physical level, then the logical level, and then it was the view level. So, physical level says how the data is being stored. Then the logical level says what data is being stored, and these two levels we have covered in our previous lectures, as in we have seen what kind of data types will be there, and how they are going to be stored, and what is going to be the structure of a relation. That means what data is being stored and the term how data is being stored, both are being covered. So, till I can say these two levels or till logical model level we have covered. Now, see what is happening here is your actual relations are stored in the database. Now, is it required or is it, I can say, desirable for all the users to see the whole logical model? That means all the fields or all the relations of all the tables are actually should be accessible to each and every user. So, for example, let us take the example of a university system. So, in the university system, if I am talking about that, there is a teachers database which is talking about which teacher is taking which particular subject, and another table or another relation is there which is talking about that about the perks or the salary of the teacher. So, account section people will be actually interested into the salary of the teachers or the perks which are to be given to the teachers, not actually what papers they are teaching. Similarly, if we talk about the admin department, they are interested in what papers are being taught by which particular teacher, not interested in the salary or the perks thing. So, basically what I am trying to establish here is it is not at all desirable for all the users to see the entire logical model. Not only desirability, but the second constraint which comes up here is about the security considerations also. So, if we talk about security consideration, we do not want a clerk who actually needs to know an instructor ID name and the department name. So, we do not want that clerk or the clerk from the admin department, let us say, we do not want him or her to get authorized to see the instructor's salary amount. So, these kinds of security constraints as well as the desirability constraints are also there. So, basically if we are going to make every the complete relation open to each and every user, then this could be a non-desirable situation. So, for example, we have a clerk who needs to know the instructor ID name and the department name. He or she will throw a we can say a select query, that is select ID name department name from the relation instructor. So, now is it not logical that instead of kind of having the giving the access to the whole complete relation or the whole complete table, the access or the kind of we can say the answer or the we can say authorization should be given for only the fields or for only the data which is actually desirable. So, here we will be able to meet our security concerns as well as our desirability concern. So, how are we going to do that? So, basically we want to have a facility here that is going through which one user can create a personalized collection of relations that is better matched to his or her intuition than a complete logical model or then a complete relation, we can say. So for example, in a relation, let's say we have 10 fields, and all the 10 fields or all these fields are not of use to a particular user. We can give the access, or he should have access to only the 5 fields which are related or related to him, or which are desirable by him. For example, let us see a situation. We want to see that a list of courses, I am talking about the particular your example which we have started from the beginning, that is the university database. So in it, a list of all course sections offered by the physics department in a particular, let us say, fall 2000 semester, with the building and room number of each section. Now this is something which is, I can say, not available in one of the relations, but this is going to come from the two relations. One is the course and another one is the section. So first of all, how are we going to fire this particular query, or how this query is being used? With the help of, I can say, this we have already seen, that how are we going to select the required data from two particular or more than one relation on the basis of, let us say, some common fields. So the query goes like this: select course ID from course. So we have written course.course ID, because course ID is something which is common to both the relations. One is the course and another one is the section. So we have we can say prefixed the course ID with the relation with the name of the relation. So select course.course ID, then section ID, building comma room number from course section, course comma section. So apart from this common field which is course ID, section ID, building and room number are either available in the course or available in the section. So that has to be taken out, but with the condition, with the where clause, that where course.course ID is equals to section.course ID. That means the course ID should match in both the we can say relation. Apart from that, the end clause follows, which says, and course dot department name equals to physics, and section dot semester equals to fall, and section dot year equals to 2009. So basically here we can say a join operation is being performed, in which the common values which is based on the field of course ID are taken from course and section, where the department name should be physics, semester should be fall, and the year should be 2009. So the query which we were talking about, that is a list of course sections offered by physics department in fall 2009, along with the building and the room number of each section should be there. Now here what we have done, we have actually we have actually fired a simple join operation, and we have computed the we can say result, and given this particular result, we have stored it in a different relation. Now this is also possible to compute and store the results of the above query, and then make the stored relation available to the user, which we just did. Now what is happening? We are actually here kind of increasing the number of relations which are available in the database, we can say huge, in a huge manner, or hugely. So for example, we can say it is also a bad idea to compute and store query results such as the just we have seen the example. So every time a different requirement is coming, we are firing a select query, we are making one different relation, and we are storing that relation into the database. So in this way the size of the database is going to explode, because every time with a new requirement, with a new query requisition, we are going to create one new relation based on that select statement, and that relation is going to be stored in, we can say a database. So is it possible to have the solution to this problem, as well as we don't want to explode the size of the database. So yes, we can say here the concept of views is here to save us. So views, we can say it's a kind of virtual relation. It is going to be defined by a query, as we are going to define the actual relations, and that relation is going to contain the result of the query which we have fired. But being the view, this is not a relation, I am talking here about the view. A view, or presently you can say it's a virtual relation. So it's a virtual relation. Now two important things are here. It is not pre-computed. Not pre-computed, that means as and when you are going to fire the query, only at that particular time, or we can say only on the demand, it is going to be pre-computed, and it is not going to be stored. So whenever the virtual relation is to be used, it is to be computed by executing the query, and there is no question of such kind of storage. So that's why we are saying this view as a virtual relation which is defined by a query, and this relation is going to conceptually contain the results of the query. This view is not going to be the part of the logical model, but yes, it is made available to a user as a virtual relation, and this is what we call as view. So view is something, when we are creating a view, the query is fired, the view is being created, and it is not stored, it is being shown to the user, and after the kind of requirement is done, or it is being shown to the user, it is not going, we can say it won't exist for a longer time. So we are not going to store that view within the database also, and as we are not going to store, it is not going to be the part of the logical model. So here we can say a large number of views can be created on top of given set of the actual relations. So for example, we have actual relations, let's say we talk about it, let's say we have 10 relations, and by the different requirements, we need different views or different virtual relations. So we can use or we can store, let's say 50 of views on top of, we can have, not the store, we can have a large number of views on top of these 10 actual relations. So these views, first of all, will be not pre-computed and stored, and they are created whenever needed on demand. That is something which is an important point behind these views. Now the question comes up, through select, we say select, and we give the name of the fields, and then the where clause, and we have from this, and we have a query fired. So how are we going to create a view? So creation of a view can be accomplished by the query, or by the statement, we can say by the SQL statement, that is create view, then the name of the view, which is v or any other, as, and then there is a query expression. So we are just not kind of throwing the query expression, or we are not going to make any new relation, we are going to make a view. So for example, we can say create view, name of the view is faculty, as select ID, name and department name from the from instructor. So from instructor table, or from instructor relation, only the ID, name and department name are selected, and they are put into a view, and that view has been named as a faculty. So the database systems are going to store the query expressions associated with the view relations, but not the view relation itself. Whenever the view relation is accessed, its tuples are created by computing the query result. Thus we can say these views are created whenever they are required, whenever they are needed, or simply we can say these views are created on demand. So for example, we have just seen one query which is we can say selecting the data from two relations. One is course and section, and the data which is being demanded is all the all the courses which are floated in the fall semester 2009 by physics department, and we also need their room number and building. So, on basis of that select statement, we can create a view so that the query corresponding to that particular view is being saved, but not the view, and as and when we need, that query can be fired, and that we can say the results can be pre-computed on results will be not pre-computed, but results will be computed on demand, and then we have one view ready with us. So, here we can say create view physics for 2009 or whatever name you want to give as, and then that select course ID, section ID, building, room number from course comma section, where course ID is equals to section.course ID and course.department name is equals to physics and section.semester equals to fall and section.year equals to 2009. So, here is the we can say the definition of the view which is available on the screen, and we can see we have just create view and the view name, and after this view name we have just given the query which we have discussed earlier. So, on the basis of result of this query, one view named as physics fall 2009 will be created and it is shown to the user. So, that is what the use of the views. They are not pre-computed, they are not stored, but yes, the query corresponding to the views can be stored, and as and when required, that query can be fired, views can be created on demand and shown to the user. So, on top of the logical model, or we can say on top of the relations which we have stored in the database, and numerous views can be created and they will be shown to the user on demand. So, for example, we have kind of fired one more query. This is just a query which says select course ID from physics fall 2009 where building is equals to Watson. Now, here the this query is actually being fired on not on a relation, but on a view which we have just created. So, please remember we have just created a view which is named as physics fall 2009. Now, what is the point which I am trying to establish here is we can use these views just as the relations. That means we can fire more precise or more refined queries on these particular views. So, select course ID from physics fall 2009, which is a view where building is equals to Watson. So, this is also permitted, this we can kind of always do, that is firing of a particular query I can say on not on a relation, but on a view is perfectly okay. So, here what is the as we have seen in the example, what is the format of this particular query. So, view names may appear in a query any place where a relation name may appear. So, query will be fired whether there is a relation, whether it is fired on a relation or whether it is fired on a view irrespective of that. So, now let us try to create, let us try to see one more example in which we are going to create another view in which we are going to fire a group by query which is on the basis of group by department name. So, we have let us see the query, that is create view department's total salary. So, here what are we going to do in this particular view? We want to see which particular department is getting kind of dispersed with how much amount of the salary. So, salary total salary as well as the department name corresponding to that particular salary. That means sum of the salary of all the instructor in a particular department will be shown corresponding to a department name. So here we have seen, here we can see that create view department's total salary, department name total salary as select department name sum salary from instructor group by department name. So we have kind of given the name of the view, which is department's total salary. What are we going to have two fields? The name of the two fields will be department name and total salary. What is going to be contained in this is department name and sum of the salary from the instructor table. With this sum of the salary, as this is an we can say aggregate method, this can be fired on a group by query. So group by department name. So here what will happen, we are going to create a view. The view name of the view will be department total salary. The two fields in this view will be department name and total salary. The department name field is going to contain plain department name, while the total salary is going to contain the sum of the salary given to that particular department, or we can say group by department name. So for example, let us say computer science department is having 4 instructor getting amount of salary as A, B, C, D. So computer science and the sum of the salary will be A plus B plus C plus D. Whatever the sum will be there, that sum will be I can say displayed. So this in this way we can create another views. Now let us say we have created one faculty value. So if we want to update, we can say here the updation in terms of I am talking about the insertion. So insert into faculty and then some values which are there. Now what will happen, actually modifications are not very freely or not generally permitted on views except in limited cases. Now why it is not being permitted or something? We can say in general SQL view is said to be updatable, that is we can perform insert or update or delete if it is going to follow some of the conditions which that query should be following, the query which is going to which is there for insertion, updation or deletion. So what I am trying to say here is, if we are going to fire a query for insertion, updation or deletion of a view, that query has to satisfy some of the conditions. Now what conditions we are talking about is, the from clause has only one database relation. There cannot be more than one relations if we are talking about the updation, that is insertion, updation and deletion, that is modification. If we are talking about on views, then it should not come from more than one relation. The from clause should have only one database relation, and the select clause contain only the attributes of the relation and does not have the expression, aggregate or distinct specifications. So expressions are not allowed, arithmetic expressions or something of that sort if we are modifying. Then aggregation also is not allowed, and also we have also seen the distinct keyword. The distinct specification is also not allowed. Now that query does not have a group by or the having clause. We can create a view by using group by or having, but we cannot, I can say modify the view by using this group by or having clause. Also any attribute which is not listed in the select clause can be set to null. That is, we can provided that attribute should not be a part of the primary key, because if the attribute is the part of the primary key of the relation, and here in the view which is made on top of that particular relation, we are setting that particular attribute to have a null thing, that is not allowed. That means whatever constraints are being capped in the original relation, those constraints should not be violated. That means we cannot set an attribute to null within a view if it is having a not null constraints or it is a part of the primary key. Both the ways, setting null to the attribute is not allowed. Also, we cannot, as I told you, that while modification we cannot use a group by or a having clause. So, under these constraints, the update, insertion and deletion operation would be allowed on the views, but apart from that, views, we can say cannot have these modification of the modification permissions if this is going to we can say challenge the constraints already put in. Now here we can say that your views can be defined within a check option clause at the end of the view definition in order to prevent this. So, for example, if we can say a tuple is inserted into the view does not satisfy the view's where clause condition, the insertion will be rejected by the database systems. Similarly, the updates will be rejected if the new value does not satisfy the where clause condition. So, we can always use the option of the check thing which is available with us, and we have already seen it in our previous lectures. With that options we can have these views having the modification facility in a constraint or in a we can say a logical manner. So, here in this lecture we have seen what is the need of views, how are we going to create the views, and what all things what modifications like update, insertion and deletion are allowed on views and under which condition. And here is a list of references which is being used for the preparation of the lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, goodbye, take care.